Here's an integral of secant cubed x times tangent squared x. We're going to evaluate it by first using the trigonometric identity tangent squared x equals secant squared x minus 1. So we'll replace tangent squared in the integral with secant squared minus 1. And then this gives us two integrals. One is integral of secant to the fifth x dx minus the integral of secant cubed x dx. In an earlier video, we evaluated the integral of secant cubed. So the integral of secant cubed, if you recall, is equal to 1/2 times secant x times tangent x plus 1/2 times the natural log of absolute value of secant x plus tangent x. So all we have to do to finish evaluating this integral is evaluate the integral of secant to the fifth. And to do that, we're going to write secant to the fifth as secant cubed times secant squared and use integration by parts. So we're going to let u equal to secant cubed x and dv secant squared x dx. Let's take the integral, let's take the derivative of secant cubed, which is 3, secant squared times the derivative of secant, which is secant times tangent times dx. And of course, antiderivative of secant squared, which is v, is tangent of x. So now we can write the integral of secant to the fifth as u times v, which is tangent times secant cubed, minus the integral of v du. And if we combine all the terms, it'll be 3 times the integral of secant cubed times tangent squared, which happens to be the original integral we are trying to evaluate. So the original integral is secant cubed times tangent squared, which we broke down as the integral of secant to the fifth minus the integral of secant cubed. And as we just saw, the integral of secant to the fifth is tangent x times secant cubed x minus the integral, or 3 times the integral of secant cubed times tangent squared, and then minus the integral of secant cubed. Let's move negative 3 times the integral of secant cubed times tangent squared to the left, combine it with the integral there, which gives us 4 times the integral of secant cubed times tangent squared, and that's equal to tangent x times secant cubed x minus the integral of secant cubed, which is 1/2 secant tangent, and since we're subtracting, minus 1/2 natural log of absolute value of secant plus tangent. And now all we have to do is divide by 4 and add c, and we have the integral of secant cubed x times tangent squared x equals to 1/4 times tangent x times secant cubed x minus 1/8 secant x times tangent x and minus 1/8 times natural log of absolute value of secant x plus tangent x plus c.